We will solve the remaining problem of exercise 12.3. So we will do question number 13. What question number 13 is saying? Question number 13 is saying in this figure 12.32, this figure, okay, a square OABC inscribed in a quadrant OPQBQ. OABC is a square which is inscribed in OPBQ quadrant, where it's saying OA is 20 centimeters. Find the area of the shaded part. That means we have to find this shaded part. How to find? You can see this OPBQ is the quadrant and OABC is the square, right? So if we subtract the area of OPBQ from the quadrant, if we subtract this square, we will find this area. Okay, now come to the solution. Here I drew the diagram. Here I drew this diagram. So again I'm saying this question. So what is given? Given is OA equal to 20, right? You can see here OA equal to 20 degree. So we know that all sides of OABC is 20 degree because it is square. So what is the area of a square formula? So here the square formula is 20, side square, that is 20 square. So that is 20 square is 400 square. Now one thing is missing for this quadrant OPBQ, that is the radius, right? Because for quadrant formula is 1/4 pi r square. So r is missing, right? If we join this OB, okay, here we wrote join, now join OB. So if we join the OB, you can see O is what? O is center and B is any point on the curved line, okay, on the circumference. The OB will be actually the radius, okay. So that means if I find OB, we'll find the radius of the quadrant. At the same time, look, OB is actually diagonal of OABC square, you can see. So now what I wrote, after joining OB is radius of the quadrant, at the same time diagonal of OACB. Sorry, it will be OABC. Okay, OABC square. Is it clear? Now radius of quadrant equal to diagonal of OABC. It's not OACB, it is OABC. Okay, diagonal of OABC square, you can see OABC square. Fine. Now R will be, what is the diagonal formula? Side root 2 into A. So A was 20 because 20 is the side of the square. Okay, so 20 root 2 will be the radius of the quadrant. Now area of the quadrant. What is the area of the quadrant formula? I told already, 1/4 pi r square. So here pi value is given in the question. In the question pi value is given 3.14. So I put pi value 3.14 here, and r square means 20 root 2 square. So then next line 1/4, 3.14. Then I taken out the decimal and writing 100 in the denominator. And here 20 square is 400 and root 2 square is 2. Okay, that's what I wrote. Then 100, these 2, 0, 2, 0 cancel, this 4 cancel. What will remain? It will remain 314 into 2. So 314 into 2 is 628. Okay, so shaded area of the shaded region, I told that area of the quadrant minus area of a OABC, right? You can see area of a shaded part will be area of OPBQ quadrant and minus area of this square. So that what I did, 628 minus 400, so 228 centimeters square. Come to the question number 14. What is question number 14? It's saying A, B, C, D respectively are the arc of two consecutive circles of radius 21 and 7 centimeter. Actually the diagram is this. Okay, this is the diagram. This diagram is saying what? That AB and CD, this arc are the two concentric circle. What is concentric circle mean? Concentric circle means when the center of two circle is same. Okay, you can see for this arc and this arc, O is the center, okay, of radius 21. That means this big radius, you can see the diagram, radius, big circle radius is 21 and smaller one is 7, and this angle AOB is given 30 degree. What you have to find? You have to find the shaded area. I guess this is one of the easiest problem. If you find from the bigger arc, if you subtract the smaller arc, you will get this area. Okay, so that's what I will do here in the solution. In the solution, what we will do, given is OB is 21, you can see in the diagram OB is 21, OC is 7, you can see this is OC is 7, and AOB is 30 degree. AOB, this angle is 30 degree. Okay, so therefore shaded area, the shaded area equal to area equal to what? That sector of having radius 21 minus sector of having radius 7, right? What I told, that this sector minus this sector. Okay, so now we have to put the sector formula. Area of a sector formula. What is the area of sector formula? I wrote here theta by 360 degree into pi r square. So theta here is 30 degree, we wrote here. Okay, AOB is 30 degree, so you can write theta in bracket. In bracket you can write theta. So theta I put 30 by 360 degree, pi r square is 21. So big arc is big radius is 21. You can see I put there. Similarly 30 by 360 degree into pi, smaller radius is 7 square. Next, from next line I will take this whole thing common. 30 by 360 pi. Here also look, both is common, so I will take this thing common. So what will remain? I am taking common 30 by 360 into pi. What will remain? 21 square minus 7 square, right? That will be in bracket. Now 30 and 60, it will be 12, 1 by 12. Pi value still I am not putting. Now you know this, what formula we will use here? We will use the a square minus b square formula. Okay, so 21 plus 7 into 21 minus 7. Okay, next line I am putting the pi value not given, that means we are putting 20 by 7. Then 21 plus 7 is 28, 21 minus 7 is 14. So 7 and if you cancel 7 it will be 2, and this cancel with the 12, it will be 3, 4 into 3 is 12, 4 into 7 is 28. So in numerator what will remain? 22, 7 and 2, denominator only 3. So 22, 7 and 2's multiplication is 308. Okay, so answer is 308 by 3 centimeters square. Now come to the question number 15. What question number 15 is saying? Question number 15 is for this diagram. In this diagram we can see ABC is a quadrant of a circle. ABC, this ABC is a quadrant. ABC, not the triangle one. Okay, is a quadrant of a circle, radius 14 centimeter. AB, this taking this curve, this is a quadrant, and semicircle drawn with that BC as diameter. So BC, you can see one line, that is actually the hypotenuse of ABC triangle. Okay, and this semicircle drawn. We have to find this shaded area. Come to the solution. You can see what before starting this one, what we have to do, how to find. You can see the shaded area. Okay, and it's saying that BC is taking BC as the diameter, this semicircle drawn, right? So if we from the area of this semicircle, if we can subtract this curve, this area, okay, we will get the shaded area. From this semicircle, if we subtract this, we will get this shaded area, right? So for that reason we have to find the area of this. So now come to the solution. Given AB equal to AC, AB and AC are saying that the radius of the ABC quadrant, right? ABC means this curve, not the triangle. AB, this C. Okay, this is 14 centimeter. That means as ABC is quadrant, BAC, this angle, quadrant means no, that this angle will be 90 degree, right? BAC I wrote 90 degree. So in triangle ABC, in triangle ABC, okay, A square plus B square, AC square plus AB square equal to BC square. What theorem? AC square plus AB square equal to BC square, right? By Pythagoras theorem we know. So AC value is given 14. AC value we got a 14 here, and AB value also 14 here. Okay, and so we have to find BC. So 14 square plus 14 square equal to BC square. So here I wrote BC equal to square root of, look, 14 square into plus 14 square. So that will be actually 2 into 14 square, right? A plus A is 2A. So equal to 14 root 2 centimeter. So BC value we got 14 root 2 centimeter. Next, now area of ABC. area of ABC. ABC is a triangle. What kind of right angle triangle? Okay, so what will be the area of ABC? Area of ABC will be half of base into height. What is base? AC, and height is AB. So what I wrote, that half into AB into AC. So half into 14 into half into 14 into 14. 2 and 14 cancel with 7. So 7 into 14 is 98. Okay. Next, the radius of semicircle. What is the radius of semicircle? BC has the diameter, right? So what will be the radius of the semicircle? It will be half of BC. So BC we got 14 root 2. So it will be actually 17 root 2. Okay, 14 root 2 by 2. 2 and 14 cancels, 7 root 2. Now, come to the most important part. Required area of shaded part. Required area of the shaded part. I told this one required area. It will be area of semicircle minus this one. Okay. So area of semicircle minus, in bracket I wrote this, area of ABC quadrant minus area of triangle ABC. Let me explain this. What is this? Now you can see this one. We have to find this area, right? How to find this area? If we, from this ABC quadrant, if we subtract the triangle, we'll get this area. Is it clear? So we wrote area of ABC quadrant minus area of triangle ABC. So area of the semicircle formula we know, half into pi r square. R of for semicircle is 7 root 2. Area of ABC quadrant formula is 1 by 4. For quadrant we know 1 by 4 pi r square. So 1 by 4 pi r for quadrant, r is 14 given. Minus ABC, area of the ABC we got here 98. So we wrote 98 here. Okay. Next with simplification, half pi value is 22 by 7. 7 square is 7 square we wrote here, and root 2 square is 2 we know. Okay. Now minus 1 by 4 pi value is 22 by 7. 14 square I wrote here 14 into 14. Now this minus will make this plus, right? So it will be 98 plus 98. Now cancellation, 7 cancel, and this 2 cancel. Okay, so what will remain? 22 and 7 and 22 will make 154. Come here, 7 and 14 will give you 2, 2, 4, 2, and 2, 11, 22 will be 11. So 11 into 14 is 154 we wrote here, and plus 98 as usual. So you can see both side, plus 154 and minus 154, it will be cancelled. So answer is 98 centimeters square. Now we have to solve question number 16. Question number 16, you can see one design is there. Okay, one figure is given. We have to find this design. Calculate the area of the design region in the figure. This figure common between the two quadrants of circle radius 8 centimeter. So this is one quadrant. This line and this curved line, and this line, and this is curved line. So this is actually a square. Look, all the sides are 8 centimeter. Okay, so you can see this is a square. So come to the solution. In this diagram I did not did in design, I just shaded. Okay, so what we have to do, I join this BD line. Okay, so that it will be very clear what we have to do. So we can now see, and we point P and Q are 2 points in this curved line. Now I can say easily A, B, P, D. Everyone can say A, B, P, D is a one quadrant. Okay, and B, C, D, Q. B, C, D, Q. This is another quadrant. Okay, from the both quadrant we have to find the shaded part. Fine. For ABCD is a square whose side is 8 centimeter. ABCD, we name this name. Okay, ABCD is a square. Now join DB. We join DB and P and Q, 2 points on the curve. That's what we wrote. Next, ABPD quadrant. What is ABPD quadrant? ABPD. This is a quadrant. ABPD quadrant. For ABPD quadrant, what is the radius? Radius is 8 centimeter. Okay. So and ABD is a right angle triangle. Look, ABD. I join ABD is a right angle triangle, right? So for ABPD quadrant, what will be the shaded part? Only this will be the shaded part. Okay, this only this part, the cross one. ABPD quadrant, only this cross part will be the shaded part, right? So shaded area of ABPD quadrant equal to area of ABPD quadrant, area of ABPD quadrant minus this triangle ABD, okay, minus area of ABD triangle. So what is the area formula of quadrant? We know that 1 by 4 pi r square. Here r is 8. So 8 square minus half into AD into AB. Why? For right angle triangle, we know that area of right angle triangle is half into base into height. So AD into AB. Now putting the value 8 square is 64, next line, and half AD value is 8, AB value also 8. Next line I put it pi equal to 22 by 7. So 1 by 4 into 22 by 7 into 64 minus 1 by 2, 8 into 8. So 2 and 8 cancel, it will be 4. Here if we cancel with 2, it will be 32, and 2 with 22, it will be 11. So here first term we having 11 into 32 by 7, and here 4 into 8 is 32. So if we take 32 common, okay, you can do calculation in other way also, but I'm doing in my way. Here we got 11 by 7 minus 1. So 11 by 7 LCM will be 7, 11 minus 7. So 4. So 11 minus 7 is 4. 4 into 32 is 128. Okay. So answer is 128 by centimeter square. Not answer. It is the shaded area of APBD. Now the interesting thing is that ABPD and BCDQ both quadrant actually are similar, identical. Okay. So shaded area also will be equal. That's what I wrote. Now shaded area of ABPD quadrant and shaded area of CDQB. Okay, shaded area of ABPD quadrant and shaded area of CDQB quadrant is equal. Okay, so shaded area of this shaded area, that I'm giving right sign, this shaded area is same, 128 by 7 centimeter square. So we have to add both shaded area. That what we got, area of shade design is 128 by 7 plus 128 by 7, LCM is 7, and 128 plus 128, 256 centimeter square. Okay, so this chapter exercise finish.